Welcome to Spring LIB.
Hello. In this problem, we are trying to determine the charge on the ruthenium ions in solution. So I want to start off by trying to put together a little equation here. We have ruthenium ions in solution, so they are aqueous. We do not know their charge, so I'm just going to call their charge X. So we have a certain positive charge, and in order to become ruthenium metal, that means this is going to have to pick up X electrons. And that will give us ruthenium metal. So now this becomes a problem of comparing the moles of electrons per mole of ruthenium. If I can get the moles of electrons, and I can determine the moles of ruthenium, that ratio, whatever to 1 ratio, is going to give me X. All right, so let's see if we can find moles of each of these. The moles of ruthenium is pretty easy. Let me start with that first, because we know we have 2.618 grams of the ruthenium, and we can divide by molar mass to get moles. So the molar mass of ruthenium is 101.1 grams in every mole. This gives me 0.0258 moles of the ruthenium. All right, so X is going to be some whole number multiple of this. It could be 1, 2, 3. So we need to figure out how many moles of electrons we have to figure out what that whole number ratio is. So let's start with our amps. We have 2.50 amps, which we know is 2.50 coulombs per second. It's another way to write amp. So let's multiply this by our time, which was 50 minutes. Unfortunately, right now my units are not in agreement, so we need to convert from minutes to seconds. All right, let's see what this does for us. Minutes will cancel, seconds will cancel. I have coulombs right now. If I solve this, let's go ahead and add on Faraday's constant here. Faraday's constant tells us there are 96,485 coulombs in every mole of electrons. All right, so this calculation should give us moles of electrons. When I calculate this out, because now coulombs also canceled, so when I calculate this out, I get 0.0777 moles of electrons. Okay, so going back to my original equation up here, this 0.0777 should be some multiple of 0.0258. So let's see about that. If I take 0.0777 moles of electrons per mole of ruthenium, I will see that I have 3 moles of electrons for every 1 mole of ruthenium. So think about what that tells me. That tells me X is 3. Therefore, the charge on the ruthenium must be 3 plus. So the charge is 3 plus would be our answer. Thank you so much for watching.